Hi guys, welcome. We're looking at week 5 here, and we're starting lesson 91 through 100. So we're in unit, actually our 10th unit. So we're getting there. We're moving right along. Lesson 91. So the week we're doing 91, 92, and 93. One day we're doing 91, and the other day 92 and 93. So 91, we are looking at evaluations with positive and negative numbers. So again, if we're ever told to evaluate something, simplify, solve, we've seen a variety of terms, but in this one we know, okay, we're given x and y values, and then we're told evaluate if x equals -2 and y equals -3. So we're going to plug those in. Again, we got to pay attention. We have a lot of negative signs to plug in and some already in our expression, so we need to be careful. We're going to go in and go ahead and plug in these. Get caught up on the page so I'm not flipping back and forth rewriting this. Okay, so we come in. We have x minus xy minus y, and then we're told to put in -2 for x and -3 for y. So as you can see, we have a lot of negative signs. So we don't want to rush through this. We want to make sure that we're taking into account everything that we need to as far as our negative signs, when we're adding negatives, when we're multiplying. So let's just start with what we know. We know we're going to multiply before we do any subtraction. So we need to multiply here. So negative times negative is a positive. So this is minus +6. Minus a negative is the same as adding. Okay, minus +6, we can just say is -6. Okay, so let's get it reduced down until we have only addition and subtraction and only one symbol between our different numbers. -2 minus 6 is -8. -8 plus 3 is -5. Okay, so we work all the way through. We first just put in our numbers, and then we still follow order of operations. Order of operations still apply when it's negative numbers. So we follow our order of operations and work our way until we get to our solution. Just pay attention to minus positive number minus a negative number. I always like to rewrite it until there's only one sign between all of them and to go from there. So example 2, Nikki says the solution to the equation 3x plus 5 is -1 is -2. Joe and Nikki can check our answer. This is something I've encouraged you guys to do since the beginning of the year. It's a test. You found X or Y or Z or whatever. Well, take a few extra seconds, plug it back into the original equation. If it works out, the left side equals the right side, you did it right. If it didn't, that's incorrect. So you can go back and check your work. So it may feel like it's just creating more work, but it's really a way to make sure that you did it correctly. So we have 3x plus 5 equals -1, and Nikki is sure that x equals -2. So let's check. So 3 times -2 is -6. -6 plus 5 does equal -1. -1 equals -1. So we know we did it correctly. Now, if we ended up with like something like this, like 5 equals 3, well, 5 does not equal 3. So we know whatever solution we started with or that we found is incorrect. So we can go back and check our work. So that's always a good idea. Maybe you don't do it on every single homework problem, but on a test, especially if you're like, oh, I don't know, that doesn't feel right, plug it back into the original equation, whatever you found, and make sure that it works out to be true. Right, so practice set. We'll go over that when we get to class. Our next lesson is lesson 92. We're looking at percent of change. So we know we always start with two parts, whatever we're adding up. If we're adding up to a whole, it's always 100% of something. 100% of students, 100% of the voters, 100% of the revenue, whatever it is, it's always 100%. So we can have an increase or a decrease to get our new number. So we're going to set up, just like we've done with ratios all before, whatever two things we're comparing, our total or our whole, which is 100%, percent, and our actual count. Okay. So now when we have that, the parts that add up to a whole, the whole or the total is always 100%. Now we may have some situations where we start with the original, we're starting at 100% and we have a change. So the dress was marked down 20%. Okay, it started at 100%, it was minus 20, so the new is 80% or whatever it is. So we have original, change, new, percent, and our actual count. Again, change can be up or down depending on what we're looking with. So let's look at example 1. In the county's population increased 15% from 1980 to 1990. If the population 1980 is 120,000, was a population in 1990. We set up our change, new, percent, population or actual counts, whatever it is. So our original was 100%. Okay, change, we were told 15% increase. So the new is 115%. Told that is 120,000. In 1980, we want to know the new population. Okay. 100 to 115 equals 120. Cross multiply. Let's multiply and divide. So the new population after the 15% increase is 138,000. Right, so we set it up for ratios just like we do red marbles to blue marbles to total or whatever two things we're comparing. In this case, the original percent is 100 instead of adding up to 100. We're starting at 100. Then our change, again, could be up or down depending on the situation, our new, and then we set up these and we cross multiply and divide. So once we have our ratios, we've done this probably a million times this year, cross multiply and divide, and we're done. Okay, let's look at example 3. A merchant bought an item at wholesale directly from the distributor, $20, and marked it up 75% to sell the item at retail. What was the merchant's retail price of the item? So again, you can shorten this somehow if you want. Original, change, and new, percent, and our money. So we were told $20 was the original, 100%. They marked it up 75%, so it's now 175% of the original. We want to know the new price. So 175 equals 20 to x. Cross multiply. So x equals 35. So $35 is the new price. So just fill in what you know, figure out what you know and what you're looking for, and then that'll tell you how to set up your ratios. Just make sure they're aligned, 120, 120, 175 and x, 175 and x. As long as they're input properly, then it just goes down to cross multiplication and division. That practice set we will do together, and then the last one we're going over this 5th week is the two-step equations and inequalities. And so we've worked with where we have 2 or more steps, and we're trying to solve for a value, an unknown. Well, what does x equal? There's going to be 1 down the road. If we have exponents, it could be more than 1, but ones we've worked with have just been one answer. But we can also look for a range of numbers, which we'll see in a second. So let's first look at this one. Again, think of it as a scale. If I do something to one side, I have to do the same thing to the other. So if we have 4x plus 1.2 equals 6 inverse operations, I'm adding, so I need to subtract. So now I have 0.4 or 0, it doesn't matter if you include the 0 or not, same thing. 0.4x, so we're multiplying, so I need to divide. And multiply, so that way I get x, 1x, x by itself. And then 4.8 divided by 0.4 is 12. Okay, so inverse operations to get x by itself, and then again, we just talked about if we wanted to double check, we could plug that back in for x and make sure that worked out to be true. And then if it wasn't true, we'd go back and check our steps and see where we went wrong. Okay, if we have this one, negative 2x, 2/3 x minus 1/2. Okay, so even though it's fractions, it's still inverse operations. We got to add 1/2. Oh, we would need common denominators. 5, 6. Once we got there, we're going to have negative 2/3 x equals, this becomes 2/6, then this becomes 3/6. We add those together, so we get 5/6. And now we're multiplying, so we divide, but when we divide by a fraction, it's the same as multiplying by the reciprocal. So I get positive 1x, just x. 2, so I get 5. Negative 5/4. And again, the negative symbol can be the numerator, denominator, or even with the division bar. Just make sure we know that it's negative 5/4. All right, so, and again, it doesn't matter if the x is on the right or the left or unknown, x, y, z, whatever. We just want to isolate it and get it by itself. So we can apply the same property to inequalities where we're looking for a range of numbers instead of just one number. If I have 2x minus 5 is greater than or equal to 1, okay, we treat this like an equal sign. There is a scenario if we have a negative coefficient, or we multiply or divide by a negative number, we may end up having to flip it. If we do that, I don't think we'll see any like that today. So just kind of keep that in the back of your mind if we do that. If we flip an equal sign, it's still an equal sign, whereas inequalities obviously are a little bit different, but it's still the same process. So I'm subtracting, so I add. Do it to the left, I have to do it to the right. Plus 5 is 6. So now I have 2x is greater than or equal to 6, so I divide by 2. Okay, and then x is greater than or equal to 3. And on our number line, Okay, it's greater than or equal to, so 3 is greater than or equal to 3, so we shade it in, and then it's moving to the right. X is greater than, so like 4. I put in 4 for x. 4 is greater than or equal to 3. Perfect. 5, same thing, 6, and so on. So instead of finding one value when it's an equal sign, we're finding a range of values when it's an inequality. Okay. And we'll go over in the future a few real world examples where we'll have inequalities. You may be saying, when do we need to have an inequality? Well, it could be something to do with temperature. It could be something to do with, revenue. We need to make at least this much money to break even. So we want to be greater than or equal to $10,000 or whatever in revenue. So it could be a lot of different examples, and we'll go over that in the future. So that is it for this week. We'll see you guys in class